Here I'm going to talk about the normal distribution. This one is a probability distribution, and why we said is normal is because most of the data we're going to find it here in the middle of the distribution, and just a few data we're going to find it here in the bottom or here in the top of the distribution. So that means that all the data that are normal distributed are going to look like this sketch that I have here. Okay, some of the important things on this normal distribution is that we're going to have that this distribution is symmetric. Okay, so in the middle of that distribution, we're going to have the mean that we're going to represent it with the letter mu, right? So it's going to be the mean, right? And the other important thing that we're going to have or that we're going to take into account is going to be the standard deviation, okay, that we're going to represent it with the letter sigma. Here, in this graph, what we're going to have is this line over here, the x. What is going to represent are going to be the values of whatever we're measuring, or whatever is that we're measuring the data, right? So let's say if we talk about the height of the trees, so here in this, what we're going to have is the height of the trees. So the mean is going to be the mean height of those trees, right? So the other thing that we have to take into account here with the normal distribution is that this the values that give me the curve, right, are going to be just the frequencies, right? So that's why we said that we have most of the data over here, because, well, the frequency here, it's pretty high, and if here we have low frequencies, right? So here, what gives the curve of this normal distribution is the frequency, right? So the standard deviation, even though it's going to be a very important very important value that we're going to take into account, it's not like we're going to, find where it is the standard deviation, right? That doesn't make sense. What we're going to do with this standard deviation is that we're going to add it and subtract it to the mean, right? So what we're going to do actually is that we're going to find, how much is it to one standard deviation, let's say over here, plus one standard deviation, right? One standard deviation. So we said that to here plus n minus one standard deviation over here. So in this case, what we're going to say is that all this data that we have here, or the amount of data that we have here, it's going to represent the 68% of our data. Okay, so actually, if I wanted to know just half of that, from the mean to one standard deviation, well, it's going to be just half of it, which is 34% of the data. Okay, which is going to be exactly the same for the other side. From here to here, it's going to be also the 34% of the data, right? Now, let's say that we're going to find this plus 2 standard deviations, right? And minus 2 standard deviations, right? So how much is going to be all this, all this data that we have here inside? So this from here to here, what we're going to have is the 95% of the data. Okay, so again, if we wanted to know how much is from the mean to 2 standard deviations above, so this one is going to be 47.5, right, percent, and the same to the other side, right? So from here to here, we're going to have 47.5%, right? Okay. Of course, if we wanted to know, like, for example, just this part, so we already know it's 34%, right? So this part over here, I'm going to just, this part over here. So if the other part it's 34% and the 34 plus this part is 47%, so this one is going to be the 13.5%, right? So again, here this one is going to be 13.5%, right? And what happened if we wanted to know how much is, what is outside, like in this part, how much is going to be this? So if we know that this part is 95%, so what is going to be outside is going to be just the 5%, right? So we wanted to know just one of them, so what we have to do is just divide it into 2. So this one, it's going to be 2.5%. So this part is also going to be 2.5%. Right? So now let's say that we have here plus 3 standard deviation and minus 3 standard deviation. So we're going to set that from here to here, we're going to have the 99%, not the 100%, the 99%, more or less. We're going to have here from minus 3 standard deviations to 3 standard deviations more, right? So again, all of this is going to be the 99%. So what it's outside this, which is this tail and this tail, right, is going to represent just 1%. So each of them is going to be 0.5, right? So this one is going to be 0.5%. Okay? So in conclusion, we have that from here to here, we're going to have the 68%, right? That from minus 2 standard deviation to 2 standard deviations, we're going to have the 95%. And that from minus 3 standard deviation to 3 standard deviations, we're going to have the 99%, right? So again, if we wanted to find, inside each of them, so here we're going to have the 34. Here also we're going to have 34, again, symmetric, so we're going to have the same. This one is going to be 13.5, 13.5. Here we're going to have 2%, here we're going to have 2%, and here we're going to have 0.5% and 0.5%, right? So that's the normal distribution. One of the problems that we can have that includes, making a sketch of a normal distribution can be something like the line of a local bus journey from Enray's home to school is normally distributed with mean of 31. So we're going to write here that the mean is 31 and the standard deviation is 5 minutes. Okay, so this one is 31 minutes and 5 minutes is the standard deviation. So when they ask to a sketch, what is important is that we have to set what is the mean. So in this case, we're not going to write the mu, we're going to write 31, right? And we're going to write, taking into account how much is the standard deviation. So in this case, it's 5 minutes. So we're going to write each of these values over here, right? So what we're going to do is just 31 plus 5. So this one is going to be, the standard deviation. We're going to write it here like 36, right? So plus 5 plus 2 standard deviation. So this one is going to be 41 plus 5. So this one is going to be 46, right? And in the other way, we have to do it exactly the same. So 31 minus 5. So this one is going to be 26, right? And minus 5. So this one is going to be 21. And minus 5, well, this one is going to be 16, right? So what we have to do when the instruction said that we have to sketch, yes, we have to take into account these values over here. And if they say, for example, okay, a sketch that, let's say that the variable here is TL, okay, we're going to call that this as the variable, the time is the variable. So they ask, draw the probability of TL greater or equal than 31, right? So what we have to do is just make the sketch and then just shade what that represent, right? That TL is greater or equal than 31. So here we have 31, and which ones are greater or equal than 31? So all these values that we have here, right? So that's what we're supposed to do in that case.